Everyone are able to see my screen?
Yes, sir.
Yeah,
Fine.
yes, sir.
Today's topic
Yes, sir.
is engineering mechanics. I hope last class everyone have received all the PPTs, my notes and other things.
Yes, sir.
Yes, sir, received.
No, sir.
I've instructed the Edwin team to share all the notes as well as last time we had few things to be sorted out. You told the links was not shared in prior, the details was not shared in prior. So I have instructed the team to give all the notes. Hope everyone have received the notes because many have missed many classes. Yeah, people.
Hello, sir.
Yes,
Yes,
sir, I am received.
Okay, maybe I'll just confirm it once more tomorrow. By tomorrow evening, I'll make sure that all the notes reach you, even including today's class also. And if anything pending, I'll make sure that everyone receives the notes and other things, other details. Okay, fine. We'll proceed further.
yes, sir.
Okay,
Yes,
fine.
sir.
Today's topic is engineering mechanics. So, engineering mechanics is the branch of physical science that studies the state of rest or motion of the body subjected to forces. It is mainly dealing with the forces. So it forms a theoretical foundation for structural machine and mechanism design. So whatever as an engineer, if you are doing it irrespective of any departments, engineering graphics, the drawing which I taught earlier, as well as this subject is should be mandatory. It is mandatory for all the departments in engineering, irrespective of the department, whether you are a mechanical engineer or computer science engineer or a civil engineer, this subject is mandatory. Everyone should know about this particular. As an engineer, you should know about this subject. The same as engineering drawing. So that is concept oriented. This is so-called theoretical as well as formula oriented. So everyone should know about this particular subject as an engineer. So this is mainly engineering mechanics is divided into two things: statics and dynamics. So, what is statics? The forces and their effects on the body at rest. So, when a body is at rest, so what are the forces and we'll see about their effects. So, that is known as statics. Everyone are clear, right? Am I audible to everyone?
Yes, sir.
Oh,
Yes,
okay,
sir.
Yes,
fine.
sir.
So statics is nothing but forces and their effects on a body at rest. So, dealing with the forces on a body at rest is known as statics. Clear, everyone? Next is dynamics. So dynamics is same thing, forces and their effects on a body in motion. So when a body is in motion, we study about the forces and their effects, that is known as dynamics. The same thing, forces and their effects on a body at rest is known as statics. Clear, everyone? So engineering mechanics is divided into two things, statics and dynamics. Statics is nothing but study of forces and their effects on a body at rest. So similarly, dynamics is study of forces and their effects on a body in motion. Next, dynamics is again divided into two things, kinetics and kinematics. When I taught the strength of materials introduction class, this is almost similar. Let it be engineering mechanics or strength of materials, you will be studying about almost all the similar things. So, types of dynamics. So, first, clear with this one now? Statics and dynamics. So, engineering mechanics is a branch of physical science in engineering which deals with the forces. So, we'll be studying about statics and dynamics. Clear, everyone?
Yes, sir.
If you're clear with statics and dynamics, we'll move further with kinetics and kinematics. So, now kinetics. So, dynamics, as I told, it is the study of forces and their effects when a body is in motion. So, it is further divided into two things, kinetics and kinematics. So, kinetics is nothing but the branch of dynamics which deals with the bodies that are in motion due to application of forces. So, listen here carefully. Kinetics, you should know the difference between kinetics and kinematics. It is a branch of dynamics which deals with the bodies and their that are in motion due to application of forces. So the motion is related to the causing force. So here you will ask questions as why a body moves, why a body moves. So due to application of forces, when you are moving in forward direction, that means something is pulled from backwards. So that is why a body moves. If you ask this question, it is known as complete kinetics. And kinematics is nothing but same branch of dynamics which deals with the body that are in motion without a reference to the force responsible for that motion. So you'll ask how the body is moving. So if you ask why a body is moving, you will tell that someone has pushed the body or it has some acceleration force. So that is completely the kinetics. When you ask how it moves, so without the application of the force due to gravity and other things, it is completely about kinematics. Clear, everyone?
Yes,
Okay,
sir.
sir.
Clear.
Kinetics is nothing but motion due to without it is similarly dynamics. As dynamics, it is the study of forces and their motion in motion, study of forces and their effects in motion. Here kinematics is due to the application of forces, and kinematics is without the reference to the force responsible. Clear, everyone?
Yes.
Fine then. So you'll be seeing the concept of forces. So if you see the concept of forces, a push or a pull. Force is nothing but a push or a pull which tends to change the state of rest or motion of a body. So when a body is in rest or it changes the motion of the body by either pull or push is known as force. Now, why force? Any doubt with the force thing? Force is nothing but a pull or a push.
Okay.
If you're clear with this, we can move further. Clear with this one now?
Okay. Clear, sir.
Okay, fine. Now you might ask why the force is required, necessity of the force, and the effects of force. So if you see here, these are the four important points, the necessity of a force. So move a stationary object. If you move a stationary object, we call it as a force. And if you change the direction of the object, when something is in motion and you change the direction, so that is also the necessity of the force. The third one is change the magnitude of the velocity of an object. So change the magnitude. You are moving in particular magnitude, you are changing the velocity of that particular thing. And change the shape of an object. So these are the four important things why a force is required. So force is required to move a stationary object, change the direction of a motion of an object, change the magnitude of the velocity of an object, and change the shape of an object. So these are the reasons why force is required. And the effect after this, effects of applying the force. So you have applied a force here. So set a body in motion. So when a body is at rest, you apply some forces in order to make it into motion and bring a body to rest. In case if some body is moving, you apply force to make it on rest position. The third one is change the magnitude of motion and change the direction of motion and change both magnitude and direction of motion. And last one, change the shape of an object. So these are the reasons why a force is required and same effects of forces. Clear with this one now?
Yes, sir.
Fine.
Clear, sir.
Next, the characteristics of force. So if you see, characteristic of force consists of these four. First one is the magnitude. The previous point I was telling about magnitude. So how large the force is applied, how large the force is, whether length wise or depth wise or whatever it is. So how large, that is known as, see if you see here, this the distance. So that is known as so-called magnitude. And direction, so direction, it may be the line along which it acts. Either it is acting horizontally or acting vertically or acting rotational force. So these are the first one is magnitude, next one is the direction. Next, point of application, where it is acts on the body. When the force, if you see here, it is act at this particular position or this particular, this F indicates force. So it is acting on a particular point. So point of application means where it is act. And the last one is line of action. So the force is moving in which direction? The straight line along the direction. Straight line along the direction, whichever force, either it is acting horizontally or vertically, if you see. So these are the characteristic of forces to be noted. So first one is magnitude, second one is direction, third one is point of application, and the fourth one is line of action. Here, magnitude is nothing but how large the force, either vertical or horizontal. Direction, either forward direction or reverse direction or rotational direction. And point of application, where exactly the force is acted. And the next one is straight line, that line of action. If you see here the line of action, that is known as the line of action. So these are the important characteristics of forces to be noted. And if you see here, the classifying the forces. So in engineering mechanics, we'll be completely studying about the forces. So if you see here, a system of forces, it is divided into two major parts. If I'm going fast, kindly let me know, because others, it should not be a one-way conversation. Everyone are clear with the previous slides, or should I repeat the same?
Yes, one question, sir.
Yes, sir, please.
You say, can you go back one page?
This one or this one, sir?
I think, yeah. How large the force is means it's similar to like size we are talking.
Yes, sir. The distance. When you push something, how
Okay.
the distance moved by the body.
Okay, so how much we are pushing any
Yes, exactly. How
parts?
much we are pushing, we are applying the force, right? So the body moves in either vertical direction or horizontal direction or rotational. So how far the body is moved. So that is called as magnitude.
Magnitude. Okay, so
Magnitude is nothing but the distance.
distance. Okay,
It can
okay.
be the
Yes.
length or the breadth or the width or whatever it is.
Okay, so magnitude is distance. Okay, so clear.
Magnitude is uh,
Mm.
clear, everyone, with this one now? Yes. Now we'll be seeing about the systems of forces. If you see the system of forces, it is mainly divided into two things. One is the coplanar forces and the non-coplanar forces. If you are able to see this particular thing, flowchart, you'll know what and all forces are there. So coplanar forces, in this one, if you see here, it is divided into collinear, concurrent, non-concurrent, and this collinear is divided into like and unlike. I'll show the diagram anyways. I'll just show this one, and by seeing the diagram, I'll explain point by point. So just see this one, and I'll go with the explanation. So system of forces is divided into two things. Main is coplanar forces and non-coplanar forces. So this coplanar is again divided into three more. So collinear, concurrent, and non-concurrent. This collinear is again divided into like and unlike. Similarly, this non-concurrent is again divided into parallel and non-parallel. Again, this parallel is divided into like and unlike. Anyways, no issues. I'll be showing the diagrams for you, clear understandings. And if you see, non-coplanar is again divided into concurrent and non-concurrent. This non-concurrent is again divided into parallel and non-parallel, where if you see, it is like and unlike forces. So if you are able to see this one, I'll show the drawings for clear explanations. If you see here, coplanar forces. So coplanar forces, are able to see the diagram?
Yes, we can see.
So if we see coplanar forces, n number of forces which is acted in different direction and different points. Are you able to see this one now?
Yes, sir.
ഫുൾ ഇംഗ്ലീഷ് ആയോണ്ട്
നിങ്ങൾ ചുറ്റിയില്ലേ മണ്ടൻ
Someone has not muted the classes. Kindly cooperate.
ഇത് ഇംഗ്ലീഷ് ആട്ടോ കേൾക്കാൻ മനസ്സിലാവുന്നില്ല ക്ലാസ്
Yeah, people kindly
ഇല്ല ഡിഗ്രി ജയിക്കുമല്ലേ
mute the same. The admin team kindly sort it out. Yeah, fine. Thank you. So coplanar forces, it is mainly dealing with the two-dimensional. So x direction, y direction, or whatever it is. So if you see here, n number of forces acting at different points. So concurrent forces is nothing but all the n number of forces acting on the same point. If you see here, F1, F2, F3 is acting on the same point. So this is known as concurrent forces. Coplanar forces is n number of forces, whereas concurrent forces, n number of forces acting on a same point. If we see here, again, coplanar parallel forces. If we see here, F1 is acted in this direction, F2, F3. But if we see, all the forces are parallel to each other. And here if we see, the coplanar non-concurrent non-parallel forces means it is acted in n number of directions. So concurrent means acting on the same point. Coplanar different directions. Coplanar parallel forces means the forces are parallel to each other, and non-parallel means acted in various directions. So this is non-coplanar forces, which is 3D system. So coplanar forces is completely into 2D. So non-coplanar is in the 3-dimensional. So here if you see non-coplanar concurrent forces, that is acting on all the forces acting on the same point. If you see here, F1, F2, F3, F4 are acting on the same point. So if all the n number of forces acting on the same point, we call it as a concurrent forces. So non-concurrent forces means acting in different directions. So there's no particular format. So forces are acting in different direction. If you see here, parallel forces, same non-coplanar parallel forces means all the forces acted are in different directions but are parallel to each other. If you see here, F1, F2, F3, F4, F5, F6, F6, F7, F8, all forces are acting in different directions, but they are parallel to each other. Clear with this one now?
Yeah, clear, sir.
So we have seen about the coplanar forces, in coplanar concurrent, parallel and non-parallel, and similarly in non-coplanar forces, same concurrent, non-concurrent and parallel. Clear with this one now? Yeah. Now if we see concurrent forces, so concurrent forces is n number of forces acting on a same point. If you see here, is it clear everyone? N number of forces acting on a same point, we call it as a concurrent forces. And n number of forces acting in different directions and not related to a particular point, we call it as non-concurrent forces. Clear with this one now?
Clear, sir.
And collinear forces, we saw about collinear forces. So collinear forces is nothing but n number of forces acting on a same plane. If you see here, it is acted on the same plane. This is considered as a horizontal force. Similarly, if we consider a vertical force also, if all the forces are acting on the same plane, F1, F2, F3, so all the forces are acting on a same plane. So that is a collinear forces. If you see a railway train means all the compartments are there, but they move in a single direction, in a single plane. So that is a collinear forces. So non-collinear forces means same. There are a number of forces acting in different directions. They are not related to a particular plane. And parallel forces, like parallel forces means all the forces are parallel to each other but acting on a same direction. If you see here, there are a number of forces parallel to each other and all the forces are acting in the same direction. If they are acting in the same direction, we call it as a like parallel forces. And similarly, unlike parallel forces means there are different forces acting in different directions, but few are parallel to each other. Clear, everyone? Any doubts in this one now?
Okay, sir.
Yeah, if I am fast, kindly slow me down so that we have
Yes,
seen
sir,
about
clear.
the.
Yes,
I'll
sir.
just.
The F1, F2, it's a force point, right, sir? Force points.
F1, F2 are different number of forces. N
Okay,
number of
okay.
forces. If you have only one force, it is F1. If you have three forces and more than two forces, whatever it is based on the numbers I've given.
Numbers. Okay, okay. Clear, sir. Clear.
Clear. So coplanar, we have seen about the coplanar forces, non-coplanar forces, concurrent and the non-concurrent forces, collinear and non-collinear forces, and parallel force system. Clear with this one now?
Yes, sir. Clear.
So this is where it is there. So system of forces, coplanar forces, non-coplanar forces, in that collinear forces, non-concurrent, and other things. Clear with this one now? So for that, different examples has been given. Now, if you see mechanics, so main thing to be noted here is three things. A particle, so body with mass but with dimension that can be neglected. So if you see, in order to, mechanics relies on simplifying models. So three things are there. One is a particle. So a particle is nothing but, if you see here, the size of the earth is insignificant and compared to the size of its orbit. So earth can be modeled as a particle when studying its orbital motion. So if you see here, so that particular earth is nothing but a particle. So if you see, when you're studying further, you can understand what is a particle. So if you're suppose if you're seeing a bike, if you see about the tire alone, so tire is considered as a particle. So in which speed the tire is moving and which speed the vehicle the acceleration is applied, likewise the particle. Next, if you have seen about the particle, next is the rigid body. See, if you see a rigid body, the combination of large number of particles. If you see, combination of large number of particles in which all particles remain at fixed distance. If you see, remain at fixed distance. So if you have n number of particles but remain at fixed, that means rigid body means it is a tough body. So it is hard to move. It is hard to, if it is a free body means easily it can move. So if it is a rigid body, if you see a heavy machine, so if you see a lathe machine or a gigantic machine means that machine will not move anywhere. You'll be working with the machine, but the machine, it is a stationary. So that is known as a rigid body, if you see. Clear, everyone?
One more time, sir, please.
Yes. A particle is nothing but, you study about the forces, right? N number of forces. So in that one, the main thing, if you are taking any particular material, so material we call in terms of engineering mechanics terms, we call it as a particle. If you consider any material, if you see a bike is there, it is a complete machine. In that, if you see any particle, a tire is a particle, acceleration is a particle separate. So clutches and other things, they are different particles. Next, rigid body. Rigid body is nothing but a gigantic body which does not move easily. It is hard to move. So it stays in a particular state at rest. So that is known as a rigid body. Clear, everyone? Yeah, people, clear with this one now?
Yes, sir. This rigid body means like we can consider like car chassis, like we can say like
Car chassis, that is a whole machine. Car chassis, car, if it is not moving, if we consider as a stationary body, we call it as a rigid body. If you see a combination of, for example, if you see uh, a machine, a lathe machine or a big machine is there. You are working on the machine, but the machine does not move.
Okay, okay, sir.
You are working with the machine, that is a rigid body.
Okay, sir. Okay, clear,
You are
clear.
in that machine, n number of forces are applied and n number of motion is there, but the machine does not move.
Oh, okay, sir. Get it,
Ah,
get it.
ah. So examples, no, I don't know to drag in the first class itself. Let me give first introduction, then we can just go further. Next, the main thing, any doubts with the force part? We have seen n number of forces. Any doubts with the force part?
No, sir.
No, sir. No.
Okay, if you've done with the force part, next we'll see the scalar and the vector part. So in engineering mechanics, we'll be seeing the, for now forces we have studied. Next, what is a scalar? If you see quantities measured with the number of units, if you see the length is measured in centimeter or millimeter or whatever it is. If you see the temperature is measured in degrees Celsius or Fahrenheit or whatever it is. Similarly, time is measured in seconds or minutes or hours. So this particular number is there. If you see, if you blankly tell length means what, how much is the length. So whether 16 centimeter length in a horizontal direction or vertical direction or whatever it is, if any number is there, so the scalar quantities are measured with numbers and units. So clear, if anywhere in engineering mechanics, if you are studying about the numbers means we call it as a scalar quantity. Clear with this one now?
Yes, sir. Clear.
Then vector quantity. So you should know about scalar and vector. So vector quantity, if you
Hello,
see,
sir. Repeat it again. Scalar quantity
ah,
in
scalar quantity, wherever you have numbers,
yeah.
in length you have number, whether it is 6
Mhm.
centimeter or 6 meters or 6
Yeah.
kilometer, whatever it is. So if you see
Yeah.
about the number means that is a
Yeah.
scalar quantity. If you see the
Number means
temperature,
this is
number,
temperature.
numbers are this particular 16 centimeter is a length.
Yeah.
So that 16 is called as a scalar quantity.
Whatever
Temperature,
the about the electricity word, this is a
that is
mechanical
also
word.
scalar quantity only, because
Mm,
volts are there. Your
volt.
current is passing in this particular volt or watts or
Okay.
whatever it is. So that is
Yeah.
also a
Yeah.
scalar quantity.
Yes. 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 Yes.
Ah. If you see the time,
Scalar
we see the
quantity.
temperature as told in electrical or whatever it is. So wherever you
But
have numbers, we
I
call it as a
know
scalar
I
quantity.
want to know in details about the what do we mean by scalar quantity in
Scalar is nothing but the numbers, sir.
numbers only.
Numbers.
Yeah.
And the unit, which unit, whether centimeter or
Yeah.
millimeter or kilometer or whatever it is.
Yeah. So whatever in electrical, suppose that 230 volts single phase, 220
230.
like this.
230 is nothing but scalar quantity, and the unit
Uh,
of that is volt.
Unit is the volt.
Yes.
Okay. Okay, sir. Thank you.
Next is the vector quantity. If you see the vector quantities are measured with numbers and units, but also have a specific direction. So particular direction is there. If you see acceleration is nothing but 30 meter per second square. So it is based on the direction and the displacement and the force. Force is mass into acceleration. So that particular, if you consider any particular direction or with respect to something, so if you have just meters, it is a scalar quantity. This meter per second square is known as vector quantity. Clear, everyone?
If it includes force, it will come in vector.
No, force is mass into acceleration, sir. So mass is in kg. So that is a scalar quantity. When it
Okay.
combines with the distance.
Okay, sir. Get it.
So force Newton meter, no sir. Newton is the kg or whatever it is, Newton meter. So that is known as a vector quantity. See, if we consider mass alone, it is a scalar quantity. Mass is in kg or whatever it is, grams or whatever it is.
If
So
anything good like mass and we are moving, it's called vector.
Yes, exactly. If you're considering any direction, we call it as a vector quantity.
Okay, sir.
So in engineering mechanics, you should know about these particular things. So we have studied about the force. So force is nothing but a push or a pull, and moment is there. Are you able to see the diagram?
Yes, sir.
Anyways, I'll share the notes. I'm just giving the examples now. So force is nothing but a push or a pull. So the formula for force is mass into acceleration. And if we see moment, so what is a moment? You have heard about moment, but how? So the turning effect of a force, the turning effect. If you see a force is nothing but a push or a pull, and the turning. So this is a force is a vector quantity. Similarly, everything is in vector quantity. So that force into d. D is nothing but the distance. So force into distance. So that particular moment in which direction it is moving. So that is called the turning effect of a force. Next, the third one is
the bolt is mass.
So where the force is applied, you are applying in one particular direction, no sir.
Yes.
In other side direction, what happens? It moves.
Okay.
So that is a moment. If you see
Moment.
force means just you are pushing the something.
Okay.
But if now in this particular end you are applying the force, and this particular end the movement is acting.
Happening.
The
Okay.
rotation is, so that is a moment.
Moment. Okay, sir. Get it.
Next is a couple. So what is a couple? Nothing but two equal opposite parallel forces. If you see a steering, one direction you are moving, other direction you are pulling it down. So that is a couple. You can move in both the direction, but the steering stays in one position only. We are just turning it. The lever and other things are stationary, but we are having the forces on both the direction. So that is a couple. Clear, everyone?
It's like a wall also. Wall.
So wall is there, but here if you see a steering means you are pulling on both the ends, sir.
Okay.
One direction you are pulling it up, other direction you are pulling it down. But steering remains in the same position, but the vehicle moves.
Okay. The couple.
So that is a couple.
Okay, sir. Okay.
Next, equilibrium. So the body remains at rest or uniform motion. We call it as in equilibrium. Now, if you see a table or a chair when placed in a room, so that is in motion. When you have parked a car, so that car is in equilibrium. There's no motion. When you have parked a car, there's no equilibrium. But in motion means you'll have forces there. So anything which is not disturbed or nothing is happening, we call it as an equilibrium. Clear with that one, sir?
Yes, clear.
Okay, then. Then in engineering mechanics, one thing to be noted is Lami's theorem. So this Lami's theorem, when three forces are acted or more than two forces are acted, so this particular formula is to be noted. Anyways, while teaching for problems and other things, I'll explain. No need to know about that thing much. I'll just tell you. So F1, F2, likewise, n number of forces are acted means, so F1 by sine alpha. So this F1 is moving in this particular direction. So alpha. Similarly, F2 is moving in beta direction, and F3 is moving in gamma direction. So F1 by sine alpha. Similarly, F2 by sine beta, and F3 by sine gamma. So this, when more than two forces are acted in different direction, we term this particular thing as a Lami's theorem. But all the three forces are in equilibrium. If you see, three concurrent forces are in equilibrium. That is, I told you, concurrent forces, n number of forces are acted, but acting on the same point. If you see, F1, F2 and F3 are there, but acting on the same particular point. Clear, everyone?
Sir, F1 and F2 force coming center point.
And weight is there. That weight is pulling downwards. That is considered as F3, sir. This W is nothing but the weight which is acted downwards due to acceleration due to gravity. So that is to be considered also. So that is the third force, sir.
Regarding this alpha and beta, we will learn when further.
Yes, sir. Alpha is nothing but the direction of F1. F1 is acted in which direction? So the degree of that one is known as alpha. Similarly, F2 is acted in which direction? Similarly,
Okay.
F3 is acted in which direction?
Okay. So we will learn this alpha means what, beta means
Yes, sir. Definitely. When going further with the problems and other things, I'll be teaching everything.
Okay, sir. Thank you.
This is being introduction to this particular subject. So I don't want to just involve much because we have seen many things. We have seen about the forces, different types of forces, scalar quantity, vector quantity. Likewise, I just don't want to go in further with the problems. So I'll just give the introduction class now. Sir.
Okay, sir. Okay.
The factor is remaining, na?
Yes, sir.
Take one. Can you go by previous one?
This one, sir.
No, sir. Previous one. We are. This is factor. You not extend, no?
Which one, sir?
This last factor.
Vector and scalar.
No. Go by that one. No. Next one.
Yes, sir.
Last.
Engineering
yes.
mechanics, that last one, na, friction, you don't extend that one, he is telling.
Which one, sir?
Friction.
Friction. Okay,
Friction.
last one. Oh, I just didn't see the friction. Okay, now we know that when a force is applied, it moves in one direction. So we are not, as I told, we are when a bike is moving, we just show about the tire in which direction it is moving and how long that is move. That is known as a force. But there is something called friction. So the tire is rubbing the road. So there is a friction happening. So we must consider about the friction also. Even if you see in a mechanical machine or electrical machine, wherever we are just having, if you are machining something, means friction occurs. So for that is the reason they are applying some lubricant. If you see a lathe machine, they are working with the machine, but what happens from one end, that particular, we are applying some fluid in order to stop the friction part. So that is important in engineering mechanics. So whatever when you're considering a force, if some pushing or pulling is happening, we should consider that particular friction. If we see here, now the force is acted in this direction. When a load is there, the force is just pushed in this direction, but friction has occurred in the opposite direction. On the surface, friction has occurred. When whatever direction the force is moving, friction will be in the opposite direction. So that is important. So wherever you're considering any force, you should speak about the friction. Clear, sir?
Yes, sir, clear.
Little bit, sir. Okay. Go by next.
Okay. Now, next we saw about the other things. Next important thing is scalar and displacements I told. So we should see about the speed and velocity. So average speed, average velocity, these and all will be studying. So being introduction class, I don't want to go in depth. I'll just tell you what is there. So that is more than enough for you to just know about. So you should know the difference between a speed and a velocity. Speed is nothing but rate of change of distance in the direction of travel. So rate of change of distance in the direction of travel. If you see a speedometer in cars measured speed, if you see in a car, the speedometer is running. So how many hours per kilometer? So that is known as a speed. If we see the velocity, so speed is nothing but distance by time. See, if we see velocity is nothing but this particular displacement by time. So displacement is nothing but rate of change of displacement. Rate of change of, that is how much the distance is moved, and we should see the rate also, having both magnitude and direction. If we consider the direction alone, we call it as speed. If we consider the direction as well as magnitude, if we see the distance alone, we call it as speed. And if we see the distance as well as the direction, we call it as velocity. So speed formula is distance by time, and velocity formula is displacement by time. There's a difference between distance and displacement. Clear, sir?
Sorry, sir. Can you give any example for magnitude? Magnitude mean?
Magnitude I've shown earlier, sir, here.
Yes.
How large the force is applied.
Okay. Okay. How large the force apply? Okay, sir. Get it. Get it.
So when we consider magnitude and direction, we call it as velocity, sir. In which line it is acted? Either vertical or horizontal or rotational or whatever it is.
Okay, sir. Get it. Yeah.
So scalar or vector we have seen. Speed and velocity. Now, as I told, 6 core concepts at a glance. So force, it showed in that particular diagram. Moment, couple, equilibrium, Lami's theorem, and friction. And the formulas for the same is given. And if you see, examples I have given, lifting a mechanism, if you see a force is there, moment, a spanner and a lever, couple, a steering wheel, and equilibrium, a beam supported design, which I have shown with the drawing. Clear with all these things?
Yes, sir, clear.
So if you
Sir,
have
can
any
you
doubts, you
please
can just
repeat
ask.
for me about Lami's theorem?
Lami's theorem. Lami's theorem with the diagram I'll show. If we see here, when two or more forces are acting at a particular point. So concurrent forces, we have seen what is a concurrent forces when two or more than two forces acting in a particular point. So if you see here, this is the point where F1 is acted, F2 is acted, and even the weight is acted downwards on the same point. So Lami's theorem is nothing but this F1 divided by the direction, this inclination. This inclination is nothing but alpha. And similarly, F2 is there. F2 is acted in this particular point, and the direction or the inclination is beta. Similarly, this gamma. So when you consider F1 by sine alpha should be equal to F2 by sine beta, and this should be equal to F3 by sine gamma.
Okay, sir. Noted. Thank you so much.
Okay, fine. Now, if you have any doubts until now, I can just brush up for the next 5 minutes. If not, introduction class, I don't want to just drag much. Maybe when getting into the problems, if you have any doubts, you can clear. Now, any doubts, you can just get it clear now. Any doubts from anyone?
No, sir. All clear.
Oh, if you're clear, well and good. I'll make sure that all these presentations have reached you on time. And if you have missed any classes also, I'll make sure that by tomorrow evening, all the notes will reach you. Because many are not attending regularly. They are coming as their time permits only. So based on that, I'll make sure that everyone receives all the notes as of now, what and all I've thought. Clear, everyone?
Okay, sir.
Clear.
Fine. Thank you, everyone. Thank you for your patient
Only we
listening.
get
Yes, sir.
only we get last year one class note, which one is beam stress and strength. This one we get it only, and there is what
Okay, sir.
how many class.
I'll just remind them once more, sir. What and all you have classed, you missed. That is from the start. What and all I have thought or people have thought. I'll make sure that the notes will reach you by tomorrow evening, sir.
Yes, sir. This is better. Thank you, sir. Thank you for it.
Yes, sir. Yes, sir. Yes, thank you, everyone. Thank you for your patient listening. If you have any doubts, you can just get it cleared, or we can just wind up the class.
Yeah, thank you, sir. All okay. Thank you.
Thank you very much. Thank you, everyone.
Yeah, thank you so much.